Thanks for coming by. I was told I'm supposed to give some kind of a introduction. That's it up on the screen, but I only got 20 minutes and I got a lot to talk about, so if you want to read it, that's fine, but we're moving on. So here's kind of like what I'm going to be talking about today, and that would be the insights to the Cybertruck. That's mine right over there. We have another one that's about 50% torn down and about 20% analyzed. And I'm going to talk to you about those things that we've seen that really excite us. And this is, as far as I'm concerned, the most exciting vehicle that I've seen in my life. And I'm old, really old, like your grandfather old, 75. And I've seen lots of stuff come and go. I was on Team Taurus. We were part of the team that developed the Mini. And all this stuff was great in its day, but this kicks real ass. And I'm telling you what, I'm hoping that we've got a lot of OEMs in here that are going to be looking very carefully at the technologies that Tesla has popped out. Now, I'm going to tell you right now, Elon Musk does not pay me. I don't have him on speed dial. He can call me. I don't know how to get in touch with him. We don't ever want a contract with Elon Musk and Tesla simply because I think that it'd be better as a conveyor of information from them to us and ultimately to you. Before I go too far, I wanted to make sure of one thing. If you guys are interested in seeing some of these bits and pieces, we have what we call in the May the 4th Be With You for EVs. This one's going to be featuring the Cybertruck, but we've got all kinds of other electric vehicles that are going to be on display. So if you want to walk through our facility, you can do it, and there's some handouts over there. This is what our current battery area looks like, and this is what we shipped last week in a way of getting rid of batteries. So we are really into EVs. Some of you here, I recognize faces. So here's the deal. Some of you know that I was an engine engineer. I helped develop the Vulcan V6, most of the Ford engines, redesigned a lot of GM engines, and I worked on monoblocks, hydrogen engines. I was an engine engineer, okay? And now I'm on the dark side. I can't believe how good it looks when we start tearing apart some of these electric vehicles, and I see this as the future, not the past, not an intermediate stage, whatever. This is it. So how do I know? Well, I can tell you for sure that what I'm going to tell you came straight from Tesla, and plus our stuff. So we've torn a lot of our stuff down. We've made a lot of corrections and changes, and if you watch the videos that we've got popping up, you'll see that it's not just kissing, okay? We actually are pointing out things that maybe Tesla should look at. But at the end of the day, no one in this room, no one in this building should be ignoring this truck. So where did I get my information from? And again, these are the videos on the bottom of the screen. They're showing the YouTube channels or whatever. You can take a picture of that, then you can go and listen to those guys. And they gave me a tremendous amount of information. We have maybe 6 or 8 hours of this stuff, but we chopped it down so that everybody can get the highlights from these different areas. Now, like I said, I've only got 20 minutes, so I have to kind of like move quickly, and this is kind of like the way it goes. So this is where we are as of yesterday. I took this picture, and we're making good progress, and something so far familiar on the Cybertruck. Like the seats go to the battery, and then the battery comes up from the floor and goes into the vehicle and is bolted into place. That's something we already saw on the Model Y. They've got advanced cooling systems, and we already know that the cooling system that they've got here is a vast improvement over the last one we saw that was a gigantic step change, and that was in the Model Y. We also are dumbfounded in some ways. So what you see there is some of the bits and pieces that we haven't really gotten into detail about yet. But I can tell you one thing for sure. Every time we turn around, there's another new surprise. Has anybody seen or heard of anything like this. This is the new vent system that they've got in the battery pack. So if you have a bad cell, then that little black dot in the orange box will allow the gas to escape. It'll also breathe, so if you're going up in the mountains or there's barometric changes and whatnot, it'll also breathe a little bit. But if you have an event, and that's a kind word for a small electric explosion, then what winds up happening is you got a lot of air to get rid, or a lot of gas to get rid of, and a lot of heat, and a lot of bits and pieces that are on fire. And that's where the spark arrestor. So on one side, you have that orange thing with a little tiny vent in it, and on the inside of the battery is that black thing, and that black thing is a spark arrestor. So the gases can get out, but the sparks stay inside. And the reason you want that is because you don't want to catch anything else on fire that's going to make the problem a bigger problem. This is one of the, I mean, it's a little teeny thing, but nobody's got it. Nobody thought of it. These are the kinds of things that I see Tesla bringing around, and everybody is eventually going to put in place. So I'm going to talk a little bit about only 3 or 4 things. One of them is the motors, because everybody kind of is interested in the motors. So what you're looking at here is Drew Baglio, and he's the head of powertrain, and we were talking about his motors and transmission and whatnot. I'm not going to go into the diffs and the little not transmissions, but gearboxes, but I am going to talk a little bit about what the migration and what the commonization is between all these different motors. So sitting here is the 2 induction motors. I was expecting that the induction motor would be in the front like all the other Tesla. It's not. It's in the back. In the back. Those 2 motors are the 2 of the this is a Cybertruck we're tearing down. It's a beast, I should say, the 3-motor vehicle. This is a clever idea because, quite frankly, if I turn off the induction motors, they don't create a resistance that's going to give me problems with my mileage and whatnot. This is a good idea. It's a fabulous idea. So we looked at that, and like I said, they've always used them in the front, but the changes that they've made so quickly, think about it. This is ponderous. In 2016, they were machining, or 2017, they were machining billets of aluminum and gluing them together and then shoving in laminates. I mean, and then they went and they picked up on the Audi idea, which was to take the laminates and then overmold them with high pressure aluminum. Well, now they've got something that's even better. I mean, this new rotor has a huge amount of integrated features. So this is one of the rotors, obviously, and if you have a look at it, you can. Sorry, we've gone to PM. Where's the other one? Somewhere along the line, I lost a slide. Anyhow, let's jump to PM motors then. So what we're looking at here is the PM motor, which is in the front. So if you have a look at the magnet V, and that would be right here, okay? It's going in and out like that. That looks very, very similar in configuration to to what we saw on the Model S Plaid when we tore that apart. But there's something unique here. It's similar, but it's not the same. Not only that, the keeper plate that you're looking at holds in the magnets and holds the laminates together. It's not as big as what you'd think. It doesn't cover the whole circumference. It only is, it exposes like at least half the magnets, and we looked at that and wondered, well, why would that be? Well, I think it's because of cooling. I think that what they wanted to do was suck more energy out, and that ability to splash oil and coolant onto the electric motor, onto the hottest part of the face, that's probably a really good idea. But nobody else has ever done it, and certainly we've never suggested it before. I have no idea why, but it's a good idea. If we look at the laminates, you'll see that instead of having a sequential step to get rid of noise, it's only got basically 2 outside steps that are similar, and then the center part of the motor has a step. That, to me, says that I should feel a pulse. I should hear a noise. But you know what? That is my car. And guess what? It's the quietest vehicle I think I've ever had in my life. You can hear the electric motor if you turn the radio off, but I can't hear the cement mixer that's right next to me. It's amazing how quiet that thing is. I don't know how or why. We haven't torn apart the motors yet, any further than that, but I can guarantee you when we get done, we'll figure it out. And then the last thing, they're going to near-net forgings. So near-net cold forgings, we've been talking about this forever, and nobody's ever done anything about it. And when I mean forever, like I've been in the business for about 50 years, and I've heard lots of people talk about, doing something that's radically different or doing something where you have to take a risk, but none of us have ever done it. This one has it. So they moved again from the old way of doing wound stators, and they moved to the hairpin, which is a great idea. This is as modern as we can get right now. It's not as good as what's on the Lucid with the woven grid, or hairpin, but I really like this. This is really a good idea. So, what makes it unique? Well, both the PM and the induction motor are the same diameter. Why didn't anybody think of that one before? They're the same diameter, and guess what? That means that the only difference here is the length of the contact stator. It's shorter on the induction motor, but the shafts are the same length. This means that I can probably wind all my stuff on one machine and never see a problem. I mean, this is the kind of stuff that I want to see as a product design engineer first, but as a manufacturing engineer, because quite frankly, if you do that, you're going to be reducing cost, waste, and weight. So, I'm going to talk a little bit about the 48 volt system. How many people here are electrical engineers? How many of you have ever tried to talk anybody in your company to go from 12 to 48 volts? I did. That was a career limiting move when I was at Ford. Nobody, are you joking? We can't, blah, blah, blah. But you look at this, okay? This is an illustration, but this is what it would look like for a cable if it was running 12 volts, and look at that skinny cable for 48 volts. Why do we want to do that? Well, let's see, does copper cost anything? Well, maybe. Does it weigh anything? Yeah, maybe. And what about the connectors? Oh, you can't get connectors, that's why we don't want to do it. There's no sensors, no connectors. How'd they build that truck then? And why are they moving everything else to 48 volts? I mean, at the end of the day, if Tesla can't find somebody that will make the sensors or make the connectors, they'll do it themselves. That is where we're losing here in North America. Well, they're North America as well, but that's where we're losing as traditional OEMs. We're missing the boat and we're not moving fast enough. So have a look at this. This is a controller out of some other car. I don't know which one they picked to take a picture of, but this is the one that will go from the front to the back of a normal sized vehicle. The one below it is the one that you're going to see when we tore apart the Cybertruck. The CAN bus system weighs 80 grams, I should say, and the Ethernet ring, which moves faster and whatever. If we look at it just the way it is, and it's like twice as long as the traditional wire one. It's at 40 grams, but if we went and did a sizing change, it'd be only 28. So from 80 to 28 grams. And then you look at the connectors. Well, if we look at the connectors on your right-hand side, you're looking at a power. Here's your power for for everything, basically, for everything. And here's your communication. And here's your power, and here's your communication. And that's as close as I could get them to size for size. And obviously it's lighter. Obviously it's less money. Who in the world would ever think that we could use a ribbon cable to do all this stuff, and that's as little as not so long ago. I was shocked when I saw this. I'm shocked about a lot of stuff, but there you go. And then I want to talk a little bit about the castings. So over there, somewhere in our little booth, we have the castings from the Model Y and from the Model Y, from both Model Ys. And if you have a look, you'll see that they're pretty big, and they're cast on machines that are approximately 8 or 9,000 tons, okay? But now Tesla has figured out how to make things a little different. And I got this straight from Lars, the guy that Lars Morvay, who's in charge of this, straight from him. They developed their own CAD system. They developed a new CFD system so they could figure out how to use less tonnage to get the same casting. So when you start fooling around with this, I don't know how many are aware of it, but these gigantic castings are formed in less than a second, less than 1 second. And that's why they don't move. There's no time for induced stresses. These are the kinds of things that we kind of like never thought about. And anybody who knows or has been to our facility, you know that I've had on my floor 15 years ago castings, a whole cast, basically rolling chassis. The thing was cast, everybody laughed at it, everybody walked away from it. Well, right now, Idra and all the other guys that are making casting machines can't push them out fast enough. All of a sudden it's become popular. That movement has to happen a lot faster for these other techniques and technologies. By the way, the one thing that I didn't mention was 48 volts. That is the enabler. That is the enabler if we're going to fool around with steer-by-wire and whatnot. We have to move quicker. That's my main message. So the material, some people want to know about this stuff. The material is A384/80, but there's magic stuff in it. We haven't really done a downtown analysis on this yet because we haven't had a chance to drill any holes in these things. But last time we found a tremendous number of little tiny elements and alloys that we would have never expected to see inside the aluminum castings. And if you look, how did they get to drop the tonnage? How did they get to drop the tonnage? Well, it's all about this. Here you go. Look at the way that this is being cast. All these things allow for quicker flow. There's no real right angles. That means that I can shove the material faster into the die, and by utilizing these ribs with like almost butterfly shapes, by doing that, they figured out how to get rid of all the little problems that would cause them to jump from like 6,000 tons to 9,000 tons. And these castings are gigantic. These are big. These other ones are huge. They are really huge. And quite frankly, they've done all the same things as what they did on the Y, including all these little cast-in-place features where I can hook something in place or I can snap something right into the aluminum. These are the kinds of things that, I mean, I've seen other companies that have tried the castings and whatnot. They're not taking full advantage of what you can do with that material science and what you can do with the types of products that you can put out. And by the way, I'm sure you probably heard about, let's look at the rear casting. So again, it's the same thing, we think, but then you've got these other castings. So this is the rear section, and this is what supports the timbre door. And over here you've got, actually it's both for the timbre door. So these don't have to be really structural. They need to be strong, but they're not something that's going to affect a crash or a rollover for that matter. So you look at these things and you say, well, what the heck's that made out of? Well, I can tell you right now it's mixed material, because we've taken 5 shots on one casting and got 5 different answers. And then we tried it on the other casting and we got 5 more different answers. So what are they doing? Why does it look like that? I think what they're doing is they're taking off the scraps, because like I say, these don't have to be structural. They don't have to be like the big castings. They're taking that scrap material and they're melting it down and shooting it. Well, why is that a good idea? Well, guess what? Engineers, we are supposed to be making money for shareholders, and that is a good idea. Is it as strong as the other castings? No, but it doesn't have to be. We're supposed to be engineers, design it for what it needs to be, not for what somebody else thinks would be a good idea. And as far as I'm concerned, anything you have to throw into a landfill or send into for recycling is a waste. I want, if that stuff is available to me and it's not good enough for the main castings, I'm not going to toss it. I'm going to find another use for it. Reuse is one of my favorite words. There's no need for the extra strength, as I mentioned. It's got the same ease of assembly features. So again, all these little places where they've cleverly made it so that the parts will either snap into a hole or they'll weave between 3 pins and they hold themselves in place. These are all little things that cut down the amount of time it's going to take to make an assembly on the factory floor. So we look at these kinds of things, and somebody's going to ask, well, how'd they attach them? They're basically just spot welds. There's nothing exotic about the way they've attached these, what I would call secondary castings to the main casting. So now, I'm sure there are doubting Thomases. So I had to do a speech in Italy for the casting stamping organization. I don't know what it was called, but it was a European organization, and they said, put us out something that tells us what's going on with castings versus stampings. Now, Munro Associates is known for like YouTube, and some people know about the benchmarking. We also design products, and we design the factories that go along with them. So I know a lot about the Mitsubishi motor assembly plant in Normal, Illinois that's now being used by Lucid. And I can tell you right now, I know how many stamping lines they had in there, I know what machines they had, I know everything, and I know how much they could do in the way of in-house without buying small secondary stampings from somebody else. The way I know about that is because the guys at Mitsubishi at one time were going to take this area right here and turn it into odds and ends type stamping. Now, we had that information, and I had the information that I had from the guys who make the molds. I am a die maker. I was a tool and die maker before I was an engineer. So we had all of the information that we needed from everybody as to how much of the stamping presses are costing, brand new, how much is the mold presses costing, brand new, how much is the material, blah, 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 everything else. Here's what we came up with. Have a look at that. That blue stuff is the reduction size in that plant. That's ponderous. What all is going on in there? Well, that's the stamping machines I don't need anymore. That's the sub-assembly weld areas that I don't need anymore. That's the subsystems areas that I don't need anymore. And that's the storage I don't need anymore. The coilers, the uncoilers, there's all kinds of, only uncoilers and straighteners. There's all kinds of things that we can do if we start thinking about the total accounted cost and not just, well, hey, a 9,000 ton press is going to cost us $9 million. That's interesting, but it's irrelevant. What is going to be the long-term effects? How many shots can I get out of this thing? How many times can I stamp something? Who's going to be making these molds and dies? All this stuff here is what we do. That's what we do for a living, a real living. I mean, the YouTube's nice, and selling reports, that'll keep us in chewing gum. But at the end of the day, that is what we do for a living. So why use castings? Tesla saved almost $200 in total accounting cost, and they got rid of 40% of their floor space. Anybody that wants to question that is quite welcome to try me out, but I will win. So, what about the other thing? Oh, sheet metal versus casting. Sheet metal is much smarter, much stronger. If you get into a crash, those castings will all break. Bullshit, bullshit, bullshit. How in the world can, let me ask you a question. How many people here have ever seen a welded together engine? Sheet metal engine, anybody? How about a cast engine? Anybody seen one of those? There's a reason why, as an engine engineer, I would use castings versus a stamped metal engine block, okay? There's a reason for that. And by the way, they aren't all made out of iron. Most of them are made out of aluminum. So I did my own little experiment. For those of you on this side, I hit this with a 12-pound sledge, okay? See that depression? I can stick my finger through it. I hit this one with a 12-pound sledge. It rubbed off the paint, okay? Same amount. And quite frankly, I may be old, but I'm not weak. And for you guys, right here, that gap, I can put my finger through. This is where I rubbed off the paint. We've got to stop the myths associated with techniques, technologies, and materials, and material science. We, as engineers, and this is all engineers, I'm assuming, we all have to get together here and start doing things a whole lot faster and a whole lot better and with a whole lot more, I don't know, guts. Because quite frankly, I'm sure it's still the same. When I was an OEM engineer, if you say no, you get promoted. Why? Because you'll never make a mistake. Never. You'll never have to be worried about the career path, as long as you just say no. And we've got to start saying yes, and we've got to start doing it in a hurry. Now, to help you out, this is my last bit of news. And I'd like to bring up Paul with me. And actually, we are making an announcement today that Autodatas and Munro are coming together to service what we think is an economy that we can help out with. So, Paul, any questions?
We're just really looking forward to this. We've been collaborating for over 10 years. We're now formalizing it for the public. We've landed several contracts together already this past year, and we've got many more coming. So, very exciting future for us.
And this will keep me from going bankrupt. Okay, thanks very much. Thank you.